there may be question or set of elements or set of values will be given to you, and what you need to do, you need to construct the AVL tree getting based on the values given. Okay, so for example, suppose values will be given, suppose 3 values will be given to you, and they will ask you to construct the AVL tree for these 3 values. So there may be more values, but right now we'll first consider the AVL tree or construct AVL tree for 3 values, and then we'll go for some extra values getting. So consider these 3 values are given to you, 10, 20 and 30, and now you need to construct the AVL tree getting. So take first element, construct the tree for that getting. So 10, we have constructed the, or we have created the node for 10 getting. So this is the first condition getting. Now take next value 20. Now what you need to do, while inserting this 20 node, you should satisfy the properties of binary search tree as well as second property, balance factor getting. Now consider this is 10. Now where to insert this node 20, to the left side or to the right side getting. So just check, just compare this 20 with 10. So 20 is less than 10 or it is greater than 10. So it is greater than 20. So it should be inserted to the right of 10, to the right of 10, to the right of 10 getting. So this is the second step you have done getting. Now take third element, 30. Now compare this 30 with 10 first. So it is greater than 10, so it should be inserted to the right side. But when you go to right side, there is one more element 20. So just compare this 30 with 20. So again 30 is greater than 20. So it should be inserted to the right of 20. To the right of 20. So this is binary search tree. But just check the balance factor. Just check the balance factor. So what is the balance factor of 30? Balance factor equal to height of left subtree minus height of right subtree. There is no left subtree and right subtree for 30. So balance factor is 0. 0 minus 0 is 0. What is balance factor of 20? Height of left subtree. Left subtree is empty. There is no left subtree. So 0. And what is the right subtree? There is only 1. Getting age. So 0 minus 1. That is minus 1 is the balance factor. Minus 1 is the balance factor. Getting. Next. What is the balance factor of 10? So height of left subtree. There is no left subtree. So 0. Height is 0. And height of right subtree. So just check the number of edges in longest path from node to its lip. So 1 and 2. So 0 minus 2. So what is the balance factor of 10? Minus 2. So is it AVL tree? No, because balance factor of root is minus 2. Getting? So what you need to do? You need to perform some activity to make it AVL tree. Getting? So see, we are what task we have been given, that is we need to construct the AVL tree for these 3 nodes or for these 3 values 10, 20 and 30. We have inserted all the nodes in tree. Getting? But we have reached to this particular situation, that is 10, 20, 30. But in this situation we got the balance factor of 10 as minus 2. That is not acceptable. Balance factor of every node in AVL tree should be either minus 1, 0 and plus 1. So this is not acceptable here. So what we need to do? We need to perform some rotations to make it AVL tree. Getting? Rotation. Rotation concept is there. So while constructing the AVL tree for given values, you may reach to some situation in which you are violating the balance factors. In that case, you need to perform some rotation activity, and based by using that rotation activity, you can convert that imbalance tree to balance tree. See, AVL tree is also called as height balanced tree. AVL tree is also called as height balanced tree. Height balanced tree, because it is always balanced. Balance means balance factor should be always minus 1 or 0 or plus 1. So here it is minus 2 for 10. So this is imbalanced. This is imbalanced tree. This is imbalanced tree. So you need to make it balance. So how you can make it balance? So by using rotation concept. By using rotation concept. Okay. So there are 4 possibilities for rotation. See, there are 4 possibilities for rotations. Sorry, imbalance. There are 4 possibilities for imbalance. Getting? There are 4 situations in which imbalance can be occurred with your tree. So first one is LL imbalance. LL imbalance. Second one is RR imbalance. RR imbalance. Third one is LR imbalance. LR imbalance. Fourth one is RL imbalance. Okay. So while constructing the AVL tree for given values, you may reach to such imbalances. Getting? So whenever you reach any one imbalance, then you need to perform the rotation. Getting? You need to perform the rotation. So if LL imbalance is there, getting? If LL imbalance is there, that means left imbalance. So what is mean by LL imbalance? LL imbalance means what? You have, or the imbalances occurred due to insertion of new node, to the left side of left subtree. That means see. Getting? So see, 3, 2, 1. So suppose recently you have inserted this node. Getting? So this is left side. Getting? Left side of this. So this is LL imbalance. This is LL imbalance. Why it is called as LL imbalance? See, you have inserted new node to the left side of left subtree. This is left subtree. Getting? Left subtree. So you have inserted one to the left side of left subtree. So this imbalance is called as LL imbalance. So in this situation, which rotation you should take? You should do right rotation. Getting my point? What is meant by LL imbalance? LL imbalance is occurred due to insertion of new node. The insertion of new node at left side of left subtree. In that case, to make it balance, you should perform the right rotation. So see how to perform right rotation. See, you should perform right rotation. How to perform right rotation? See, you should perform right rotation like this. That means, see, one node will be pushed to the upper side. That means one node will take place of two. Two node will take place of 3, and 3 will be pushed to the down. 3 will be pushed to the downside. See, so 1 will take place of 2. 2 will take place of 3. So when you do this, automatically 3 will be pushed to the right side to the downside. Getting? Downside of right side. Getting? So this is what right rotation. So if there is LL imbalance, you should do right rotation. Getting? So this is what now you can check the balance factor of this 0, 0 and 0. So this is balance AVL tree. Getting? Now what is next thing? Now see what is RR imbalance. So see here we got RR imbalance. What is? We got RR imbalance. This is imbalance tree. So see, recently we have inserted 30. So what we have done? We have inserted new node to the right of right subtree. And because of that insertion, you got RR imbalance. So what is meant by RR imbalance? RR imbalance is occurred due to insertion of new node at right side of right subtree. Getting? So that is called RR imbalance. So RR imbalance, whenever you got RR imbalance, you should do left rotation. You should do left rotation. So how you are going to do left rotation? You should rotate this tree to the left side. Just we have seen how to rotate tree to the right side. Now opposite to that. So see, 30 will take place of 20, 20 will take place of 10, and 10 will be pushed to the downside of, yes, 10 will be pushed to the down of right side. Getting like this. So see, 30 will take place of 20, 20 will come here, and 10 will come here. Getting 10 will come here. So see, now you can check the balance factor of this. Balance factor of this. See, tree will be like this. Balance factor of all node you can check. 0, balance factor is 0 here, 0 and 0. Getting? So this is what balance tree now. Getting? So we have seen whenever we got LL imbalance, then we should do right rotation. Getting? Whenever you get RR imbalance, then you should do left rotation. You should do left rotation. Getting? Okay. So this is what two rotations we have seen: LL imbalance and RR imbalance. Okay. Okay. Now we'll see third imbalance, that is LR imbalance. Okay. So left right imbalance. So when this imbalance occurred, so LR imbalance is occurred when we insert new node to the right side, of left subtree. Getting? So see, LR imbalance is occurred when we insert new node to the right side of left subtree, to the right side of left subtree. Getting? So see, suppose this is 4, suppose this is 2 and this is 3. Getting? So I have inserted, getting, 3 node to the right of 2, getting, which is nothing but left of 4, that is left subtree. Getting? This particular tree left, it is left subtree of 4. Getting? So what I have done, I have inserted new node to the right of left subtree, like right of left subtree. So such imbalance is called as LR imbalance. LR imbalance. So in this case, in this situation, you need to perform 2 rotations. You need to perform 2 rotations. That is called a double rotation you need to perform. In case of LL imbalance, you should perform only 1 rotation, that is right rotation. In case of RR imbalance, you need to perform left rotation. But in these 2 cases, LR imbalance and RL imbalance, you need to perform 2 rotations, double rotations you need to perform. So see, this is LR imbalance. You have inserted new node to the right side of left subtree. So that's why there is a imbalance, LR imbalance. So which rotation we should do next? So see, you should rotate this tree to the left side first. You should rotate this tree to the left side first. So how to perform left rotation here? See, what you need to do, you need to shift this tree to right direction. Getting? So that means this 3 will take place of 2. Getting? 3 node will take place of 2. Whenever you perform this activity, 2 will be automatically pushed to the right downside. Getting? This 3 will take place of 2. Automatically this 2 will be disconnected from this and it will be shifted to the left side. It will be shifted to the left side. Getting? So see, this 3 will take place of 2. Automatically 2 will be shifted to the left side. That is nothing but left rotation. This is nothing but left rotation. Getting? So see, now just check the balance factor of this. So 0 here, balance factor of 3 is what? So height of left subtree, that is 1 minus 0, so 1. Getting? And height of 4, that is height of balance factor of 4, that is height of left subtree, that is 2, and minus 0, that is 2. So see which imbalance you got now. You got, see, you have inserted, that means you got LL imbalance. Getting? This is called LL imbalance. So again you need to do which rotation? Right rotation. You need to do right rotation. Getting? So see, whenever there is LR imbalance, you need to perform two rotation. Getting? First rotation is left rotation and then right rotation. Getting? So what will be right rotation here? What is right rotation? We have already seen that. What is right rotation? See, this 2 will take place of 3. 2 will push to the upward direction. Getting? So 2 will take place of 3. 3 will take place of 4. Getting? 3 will take place of 4. Getting? And automatically this 4 will be shifted to the downside of right. Getting? So 4 will be pushed to the right side. Getting? So that is what right rotation. So see, now you can check the balance factor of each node. So they are 0. So this is what LR imbalance and the rotations. So two rotation, double rotation you should take in case of LR imbalance. First left rotation and then right rotation. Getting? So this is LR imbalance. LR imbalance. Now last imbalance is RL imbalance, that is right left imbalance. Right left imbalance. So what is meant by right left imbalance? Right left imbalance is occurred due to insertion of new node to the left side of right subtree. Getting? Right left imbalance is occurred due to insertion of new node to the left side of right subtree. Getting? So see, left side of right subtree. So consider, suppose this is 4 and take here 6 and then 5. Suppose these are the nodes 4, 6 and 5. So see what I have done, I have inserted 5 recently. So I have inserted 5 to the left of 6. Getting? But 6 and 5, this is a right subtree. This is a right subtree. So I have inserted 5 to the left of right subtree. To the left of right subtree. Getting? I have inserted 5 to the left of right subtree. So this imbalance is called as RL imbalance. This is opposite to LR imbalance. This is what? RL imbalance. So again you need to take two rotation, double rotation. So first, which rotation you should take? Right rotation. You should take right rotation. Sorry. You should take first right rotation. So how to take right rotation? See, this 5 will be pushed to the right side, that is upward side. Then automatically 6 will be pushed to the right side, that is to the downside. Getting? So 5 will take place of this 6. 5 will take place of 6. Then automatically 6 will be pushed to the downside, that is right side. Getting? This is what? Right rotation. This is right rotation. Getting? And just check which rotation, which imbalance you got now. See, just check the balance factor of each node. 0 here, -1, and here -2. Getting? 0, -1, -2. So see, here there is imbalance. Getting? This node is violating the property of balance factor. Getting? Balance factor property it is violating. So now you got a right imbalance. So which rotation you should do? You should perform, see, in case of RR imbalance, you should perform left rotation. You should perform left rotation. So how we are performing left rotation? 6 will take place of 5, 5 will take place of 4, and 4 will be shifted to the downside of left. Getting? Downside of left. So see, 6 will take place of 5, 5 will take place of 4, 4 will be shifted to the left side. Getting? Like this. So this is left rotation. This is left rotation, and now just check the balance factor of each node. 0. So this is what? Balanced AVL tree. So these are the 4 type of imbalances that may occur while constructing the AVL tree. So you should remember these imbalances. Getting? So there will be list of elements given to you, and they will ask you to construct the AVL tree. So while constructing the AVL tree, you should take element one by one, and you should follow the properties of AVL tree. That is, it should follow the property of BST, and you should check every time. You should check the balance factor of every node. It should be either -1, 0 and +1. Getting? And if any imbalances occurred after insertion of any node, then you should take appropriate rotation to make it balance one, and then you can continue the same steps. Getting? So this is all about AVL tree definition. So AVL tree was invented by 3 computer scientists, Adelson, Velsky and Landis. Getting? And why it was invented? Because there was a drawback of binary search tree. Getting? If the binary search tree is in the form of left skewed or right skewed, then also we are getting the big of n complexity, that is worst time complexity. So to make it or to get the good complexity, or to get the quick searching operation, we are going for AVL tree. Getting? But AVL tree should have 2 properties. First thing is AVL tree should be binary search tree, and second thing is there is a concept of balance factor. So balance factor of every node in AVL tree should be either -1, 0 or +1. Getting? So this is